In this lesson, we're going to solve systems by elimination. So example number 1, how do I use addition to eliminate a variable? All right, so I'm going to solve the system by eliminating one of the variables. So what I'll do is I'm going to start by looking at my equation, and I'm going to use addition in order to eliminate one of the variables. And so I'm going to look for an area where two numbers where they can cancel out by adding these two equations together. So if I look right here, I have a positive 2 and I have a negative 2. And so if I were to add these two together, I would then, these two would cancel out, and then I'm going to just continue adding everything else that I have in this system. I'll take my 3y plus my 5y and I'll have 8y. And then I'm going to add my 11 plus 13, and I'm going to have 24. So once we've eliminated that variable, now we're going to solve for the variable that we have there. So I'm going to divide everything by 8, and I'm going to have y is equal to 3. Okay, so now we need to solve for the other variable. We're looking for to find out what both variables are, and we know what the y is. So what we're going to do is we're going to go up here and we're going to substitute in this y is equal to 3 into one of the equations up top. I'm just going to take this first one up top here. I'm going to go back and I'm going to take this 2x plus 3y is equal to 11. So what I'm doing is I'm going to say that y is equal to 3, and then I'll be solving for the x. So I'll take 2x plus 3, and now what I'm saying is that y is equal to 3 is equal to 11. So I have 2x plus 9 is equal to 11. I'm just going to continue solving, minus 9, and then I have 2x is equal to 2. Then I'm dividing by 2, so we know that x is equal to 1. So the place in which these two equations are going to intersect on the graph would be at the point, I'll change the color here, at the point 1, because x is equal to 1, and my y is equal to 3. So the solution to this system is 1, 3. If you were to graph both of these, you would find that at the point 1, 3 that they would intersect. Example number 2. We're going to again try to eliminate one of the variables by using addition. Notice that the negative 3y and the plus 3y, those will cancel out to be 0. So I have now canceled out my y's. So let's go ahead and take a look. I have 4x minus 2x, or plus negative 2x. I'm left with 2 x's. Now I have my 5 plus negative 7, and I'm going to get a negative 2. So I'm going to continue by solving by then dividing by 2, and x is going to be equal to negative 1. So now that I have my x is equal to negative 1, I'm going to go back up and I'm going to take either one of the equations. It doesn't matter which one I take. I'm going to use this one right here and then plug the negative 1 in for my x. So I'm going to use the 4x minus 3y is equal to 5. And we're going to plug in the negative 1 where we have the x. And remember, a number right next to the variable means that it's multiplying. So we have negative 4 minus 3y is equal to 5. We're going to add the 4. And negative 3y is equal to 9. And then we're going to just divide by negative 3. And so y is going to be equal to negative 3. So the solution to this system here is going to be, they're going to cross on the coordinate grid at the negative 1, negative 3. All right, so how do I use subtraction to eliminate a variable? Solve this linear system. So I have 4x plus 3y is equal to 2, and 5x plus 3y is equal to negative 2. All right, so if you'll look at these, there's no, I can't add these together to have one of the variables be eliminated. But what I do notice is that I have two 3y, so a 3y and a 3y. So if I wanted to then solve the system by subtracting, what I would have to do is to go through and subtract everything in this system. So I would take 4x minus 5x, and I would have negative 1x, or just negative x. 3y minus 3y, that would cancel out. And now I'm looking at 2 minus negative 2. That looks like 2 minus negative 2. Those two negatives become the positive, and I have 4. So I would then divide by negative 1, and x is going to be equal to negative 4. Another way that I like to look at this is I like to go and multiply everything on the bottom by a negative 1, because I find that it's a little easier than a lot of times we'll drop that. Two negatives make a positive. So what if I went and I have 4x plus 3y is equal to 2, and I have 5x plus 3y is equal to negative 2. So if I went and I multiplied every part on the bottom by a negative, I would have a negative, this would become a negative, and then multiplying a negative times a negative, this would become a positive. And I always like to add them. So we can subtract them or we can add them, but before you can add them in this, using this method here, you'd have to multiply everything by a negative, because now you'll notice that that's going to cancel out. 4x minus 5x, I have a negative 1x, and then I have 2 plus 2 is equal to 4. So notice I'm going to end up with the same answer. My x is equal to negative 4. Okay, so now that we know that x is equal to negative 4, now we have to go back up and we have to insert it or plug it in to one of the equations. Again, I'm just going to take this first one up here, and I have 4x plus 3y is equal to 2. What I'm saying is that x is equal to negative 4, so that negative 4 is going to be plugged in for my x. All right, so negative 16 plus 3y is equal to 2. Plus 16, and I have 3y is equal to then 18, and I'm going to divide, and we're going to say y then is equal to 6. 18 divided by 3 is 6. So now our solution then, our x is negative 4, our y is 6, so the point at which they are going to intersect on the graph is going to be at the point negative 4, 6. All right, so for number 2, we have 7x minus 2y is equal to 5, and then we have a 7x minus 3y is equal to 4. So again, notice I have two 7x's, but a positive 7x does not cancel out a positive 7x. So we could go here and we could subtract, take 7x minus 7x, and I get 0 x's. And then I could take negative 2y minus negative 3y, and I'd have to be then adding that. And that's why I like to, when I have these subtraction ones, I like to go and take the opposite of everything, because you are subtracting then, and you don't have to think about it as much when you've got those double negatives. So I have 7x plus negative 7x, and I'm going to have 0 x's. Those are going to cancel out. Negative 2y plus 3y is going to give me a y, or just 1y, is going to be equal to then 1. So we know y is equal to 1. Now we're going to, just like we did the other ones, we need to come up here and to the top, and I need to pick one of the equations. And it does not matter if you take one of the original ones, if you take one that you've rewritten. I'm just going to come back up here, and I'm going to use this one right here. I have 7x minus 2y is equal to 5, and I'm plugging in the y. So I have 7x minus 2 times 1 is equal to 5. 7x minus 2 is equal to 5, and I'm going to add my 2. And 7x is equal to 7. So I'm going to divide by 7 on both sides, and x is going to also be equal to 1. So the solution to the system, the point at which they're going to cross, would be at the point 1, 1. And in our last example, we're going to look at what happens or what you need to do in order to solve if your terms are not all in the same order. So notice how I have 8x minus 4y is equal to negative 4. And then I have 4y is equal to 3x plus 14. So I'm going to put them both in standard form. This first one where I've got the 8x, so I'm just going to rewrite it down here. Minus 4y is equal to negative 4. I'm not going to do anything different with that. What I need to do is I need to get my x's and my y's on the same side. So notice for the second one, if I were to rearrange this, I could subtract 3x on one side, and if I do that, I have to do that on the other side. So basically what I've done, and now you have to be careful here because I have a negative 3x because I subtracted it from the other side, and now I've got a positive 4y is equal to 14. So if you ever go and you're trying to eliminate things and they're not written in the same form, you need to rearrange them so that they're both in the same form. So now all my x's are lined up, all my y's are lined up, and now my numbers are all lined up as well. And now if I look at this one, I'm going to look to see, can I eliminate something? Yes, I can take this negative 4 plus 4. That is going to cancel out. So I don't have to go and subtract anything or try to make something do the opposite. So 8 minus 3 is 5x. That other canceled out, and I'm going to have negative 4 plus 14 is 10. I divide by 5, and so x is going to be equal to 2. So now that I have my x is equal to 2, again, now the last step there is you have to go and you have to substitute in that variable for where you see an x. So I'm going to take 8, and my x is 2 minus 4y is equal to negative 4. 16 minus 4y is equal to negative 4. So now make sure this is a positive 16. I'm going to minus 16. Also, don't drop that negative with that y. So now divide by negative 4, and y is going to be equal to positive 5. So the place at which they're going to intersect, or the solution to this inequality, or I'm sorry, this linear system, is 2, 5. X is 2 and y is 5, so that is a place in which they would intersect. And our last one here, I'm going to rewrite this 2x plus 5y is equal to 12 because that's in standard form. I want everything to line up. So I have 2x plus 5y is equal to 12. Notice how my x and y are not on the same side for the second one. So I'm going to minus a 4x on both sides. And then make sure when you do this that you write your minus 4x right here. And I have a positive 5y is equal to 6. So now if I look at this, I notice I have 2 positive 5y's, but they're not going to cancel out. A 5 and a 5 will not cancel out, but a negative 5 would. So if I go and I take the opposite of everything here, basically what I'm doing is I am subtracting, but I'm kind of keeping track of it. All right, so I have 2 plus 4 is 6x. Those canceled out, and 12 minus 6 is 6. So I'm going to divide by 6, and I'll have an x is equal to 1. All right, and again, we're just going to plug it in to one of these and solve. So I'd have my 2 times 1 plus 5y is equal to 12. And would have it mattered if I had used the 5y is equal to 4x plus 6? Or if I had used this one right here? No, that doesn't matter. You're just using one of them. You'll get the same answer. 2 plus 5y is equal to 12. Minus 2, and so you have 5y is equal to 10, so I'll divide that by 5, and I'll have y is equal to 2. So the answer to this one, where they're going to intersect, or the solution to both of these equations, is x is 1, y is 2, and so my solution to this is 1, 2. So in this lesson, we took a look at how to solve linear systems using the elimination method.